Unit 2 is called The Organization of Matter, and it begins with a historical look at the development of the atomic model.
Now we begin with the ancient Greeks. And back in the time of the Greeks, there was all philosophers, and everything they did was just thinking and wondering why things were the way they were. So when they first came up with the idea of the atom, they decided that things must be able to be divided into the smallest thing. And the smallest thing is what they call the atom. And this was very untestable and unsupported because we didn't have experimentation back in these times.
This is a famous quote by Democritus, who was the first one to suggest that matter was made up of atoms. He said, "Nothing exists except the atom and empty space. Everything else is opinion." And doesn't he look like a jolly old fella? I think that was a great picture.
Yeah, he does look very happy.
Yeah. There was very little progress that was made in the study of the atom until around the 17th century, when a group of individuals called alchemists started investigating the universe. They had an early belief in earth, fire, air, and water as the four constituents of matter, but they gradually isolated more and more compounds and elements without even realizing that they were starting to unravel some of the secrets of and mysteries of our world. It's because of their development of experimentation that we eventually were able to determine what we know now about atoms.
Now, didn't the alchemists believe that everything could be turned into gold?
Well, they had this philosopher's stone thing, and they thought they were trying to turn lead into gold. But, I don't know that much about them, but they were kind of a cross between real experimenters and maybe magicians that wanted to turn things into gold, which of course they never did, but their contributions to science were really great because of their development of experimentation.
Of course, with the cost of gold today, it'd be nice if we could turn everything into gold.
That'd be cool.
I know.
We could be rich.
We could be rich. Okay, so in the mid 1700s, mid to late 1700s, Joseph Proust came along and developed what was called the law of definite proportions. And what he determined was that different samples of pure substances contain the same proportions of elements by mass. So he actually started looking at compounds and seeing if the ratios and the proportions of the elements were the same. And he determined that there must be some sort of constant composition or proportions that exist within each compound.
The next person that contributed to our ideas was Antoine Lavoisier. He was doing experiments and showed that if he combusted a compound, which means it reacts with oxygen, in a closed system, which means nothing can escape or nothing can enter, there's no loss of mass. So whatever mass you start with, that's the mass you end up with. This led him to develop the law of conservation of mass, which states that mass can neither be created or destroyed in chemical reactions. And so much of chemistry is based on this. When we start writing balanced equation, it's based on the conservation of mass.
And stoichiometry.
Oh yeah, stoichiometry, all that stuff.
After Lavoisier came along John Dalton, and he combined the law of definite proportions by Proust and the law of conservation of mass by Lavoisier, and formulated what he called the atomic theory. And the atomic theory was based on experimentation.
He's like the first one that kind of looks like a nerd.
Yeah.
He was actually a school teacher, though, and he was doing experiments in his barn or something like that. Okay, so Dalton in 1803 linked the existence of elements, which cannot be decomposed chemically, to the idea of atoms, which are indivisible. And from this, he wrote several postulates.
And you really should know all four postulates to John Dalton's atomic theory. The first of the four postulates states that all matter is made up of atoms. He said that they were indivisible and indestructible, and that they are the ultimate chemical particle.
He also said that all atoms of a given element are identical, both in mass and properties, and atoms of different elements have different properties. Now, there's been some changes to this in the past, 1800, in the past 200 years, but we'll get to that later.
Next to the postulates dealt with compounds, And he said that compounds are formed by the combination of two or more different kinds of atoms, and that the atoms combine in ratios of small whole numbers. So, for example, one atom of A will combine with one atom of B, or two of A with one of B, and something that would sound familiar to you, take water, for example. Two hydrogens combine with one oxygen, or you could have two hydrogens with two oxygens. They're always going to be in small whole number ratios.
Yeah, and the image that you're looking at is actually from John Dalton's notebook, where he came up with symbols for the elements, completely unlike the ones we have now.
I like the peace sign one.
Yeah, and the thing is, he's got some things like lime. Lime is actually a compound, and soda is actually a compound, and potash is actually a compound, but they didn't have everything perfect back then. But he had symbols for the elements, and then to the right you can see that he put those element symbols together to show how compounds were formed. So, it's basically the same thing that we're working with now. It's just that we have better knowledge as to what's a compound.
Yeah, that's actually a really cool picture.
Yeah, I like that.
Yeah.
The last postulate was that he said that atoms are the units of chemical change. And when a chemical reaction occurs, atoms can rearrange themselves, but they combine differently. They can separate, whatever, but they cannot be created, destroyed, or divided into parts, or converted into any other atom. So if there's an atom of oxygen on the left, there's going to be an atom of oxygen on the right. It's not all of a sudden going to become copper because of a chemical reaction.
Now, John Dalton's postulates and his atomic theory actually explain Antoine Lavoisier's law of conservation of matter. The matter cannot be created or destroyed because of atoms cannot be created or destroyed. That agreed with postulate number 4 of John Dalton's atomic theory. And then the law of constant composition, the one that states that all atoms of a given element are identical and all compounds are formed by atoms in small whole number ratios. That, I believe, agrees with postulates 2 and 3 of John Dalton's atomic theory.
Yeah. Okay. And then as a result of his atomic theory, he proposed a new law called the law of multiple proportions. This says when two elements form two different compounds, the mass ratio in one compound is a small whole number times the mass ratio in the other. And if you think about this in terms of, for example, carbon dioxide, which is carbon with two oxygens, and carbon monoxide, which is carbon with one oxygen, the amount of carbon is constant, the amount of oxygen is doubled. So the small whole number is 2. So you've got twice as much oxygen, so you're going to have the mass of oxygen is going to be twice as great. So that came from the combined and small whole number ratios.